This video is to hopefully help anyone experiencing no air coming from the vents in your vehicle. I had this problem in my Pontiac Vibe. I want to show you the steps I took to diagnose the issue, and near the end of the video, I'm going to suggest what I think is the best diagnostic tool to start with. The good news is you already have this tool most likely, and it's very inexpensive. Give me a moment while I mount my camera above my workbench. So the first test I did was to hit the dash. I used the palm of my hand to hit the area where the blower motor is. The fan started working again, confirming a connection problem in the electrical circuit. So the second test was resistor bypass test. I set the blower speed on high and it still didn't come on. That indicated it's not a resistor problem because the resistor isn't used on high. It's only used on the lower speeds to slow the fan down. Next, I did a pin fitment test and I cleaned the connectors, and I'll show you the little kit that I kind of made up from an old eyeglass case. So these electrical contact cleaning tweezers I use to clean the male pins, and then I use this carburetor cleaning kit to find the appropriate diameter rod that would fit pretty snugly in the female connector, and I went into the female connector and just scuffed it up, just removing anything in there that's not supposed to be there. So, having tested that, I meant to tell you that I found a female pin that was very loose. Where the male pin went into the female pin, the female was extremely loose. So the male pin, in my thinking, was not making a good contact. I tightened up that female terminal and put the blower back in the car. Honestly, I thought that was the problem, but weeks later, the problem returned. So next, I did a brush contact test with the oscilloscope and with the test light. So I connected the test light as shown here. This tests for breaks in the circuit, even in places you can't see, like the brush contact with the commutator segments inside the motor. Let me show you those brush contacts. So taking the cover off, these are the brush contacts. There's a brush here, and this shiny brass copper section, this is the commutator segments. So the test light never blinked during this test. So the blower passed the test light test. Next, I did an oscilloscope test. I have a picoscope, and I realize most people don't have one of these, but I'll show you that test in a separate video. And forgive me while I grab my cell phone and move it. So this is the oscilloscope trace. So the blower motor was off. I connected the battery. It ramped up. It maintained roughly 10 volts on this old and not very often charged battery. But there's no dropouts. So dropouts back down to 0 would have indicated that the brushes were losing contact with the commutator and the motor would stop. So the motor passed that test, I'd have to say, based on that. Here is the setup for the oscilloscope test and the test light test. This is the old blower motor after taking the back off of the motor and blowing the dust out, which seems to have made a pretty big improvement. But here is the oscilloscope test first to see if there's any indication that the brushes are still losing contact with the commutator segments. After that, I will do the test light test to see if the light dims or goes out, indicating lost contact with between the brushes and the commutator segments. So here comes the oscilloscope test first. Okay, and now I will do the test light test. So connecting the test light, connect this into battery positive, connect this to battery ground, test light lights, and now going slowly to see if there's any indication of that test light going out. That is it. So the blower seems to have passed both the oscilloscope test and the test light. Why did the test light not reveal the problem? I can't fully explain that. I did that test before blowing the dust out of the motor. Quite a lot of old brush dust was in there. In fairness to the oscilloscope test, I wish I had done that test before blowing the dust out. I assume that dust may have been getting between the brushes and the commutator segments and intermittently breaking the connection. So, all of the tests I've done so far, none of them caught the problem. The one common factor in all of those tests was that I removed the blower from the car, disconnecting things before doing the tests. I wanted to find a way to test without disturbing anything prior to the test, so I removed the cabin air filter so that I could see the fan blades. I used an unconventional diagnostic tool, a straw, to reach inside and rotate the fan. It instantly roared back to life. The straw slightly rotated the commutator, which changed its position against the brushes. Of course, this is with the fan on, but not working. That straw instantly confirmed this was a brush contact problem. Let me show you. So, reaching in and slightly moved the blades of the fan. Here's what happened when those fan blades moved. Take a look at this copper commutator segment. As soon as the fan starts to turn, the commutator segments, they move. That changes their position against the brushes. So this straw 100% definitively confirmed that the problem is between the brushes and the commutator segments. So had I used the straw first, I could have saved a lot of time and trouble. So if you have this problem, do the straw test first. Apparently, nothing gets past the straw.